Thank you, Nikki. Okay, am I on? Yep. All right. Okay, so we've had our very teeny tiny morning tea break. I hope you all are adequately caffeinated, and now we're approximately back on time, so that's good. Today I'm going to be talking about Pygame Zero. So I'm a teacher. I've been a teacher for a while now, and there's a thing called Pygame that most people that are Python developers know of and never, ever, ever touch, because who would? But there's also another thing called Pygame Zero, and I'm going to be doing a bit of an analysis of the two today and telling you about my story in the classroom so that any educators that are watching can understand some of the pitfalls that I've come across and how to avoid them in their own classroom, and some of the benefits also. So the summary is Zero or Hero, Pygame Zero in the classroom. So who am I? This is my fabulous game avatar that my son made me. So I'm a computing teacher and have been for about 15 years. I used to work in industry, but it's getting to be an embarrassingly long time ago now. And I am concerned about the implementation of new syllabuses in New South Wales. We're getting a lot of them over the next 2 years. And I am a terrible kickboxer despite this image. Okay, so this is a quote by Pablo Picasso that, and I'm not a big fan, I've got to say, but I'm a big fan of this quote, and I do take it on. I synthesize this in my classroom. So we learn the rules like a pro so we can break them like an artist. And so this means that I have a slightly different take on teaching computing from a lot of teachers. And this dovetails quite interestingly with Jack's talk, because I steer clear of libraries for the most part, at least for the first phase of programming. Some teachers go in with lots of libraries very early, get the kids to feel that efficacy of making stuff happen, and I am a bit more like the first principles. We have to have that foundation. And so the transition that we make in the classroom in my programs, programs are the teacher word for like the things we do in the classroom. They're all written into a program. And so our programs start with output. We have print on the screen real early. That hello world thing, that's true. We print on the screen real early, and then we add some variables to that, and then we add some input so we can see what the user is typing, and then we might do some string processing in there so that the students get a lot of practice at that. And then we add selection, which is your if statements, and then we make complex selections, so nesting of if statements, and elif gets added in there, and then we have loops added, start with while, transition to for, and then we have loops with selections, loops with other loops. Like this is the growing ripples of computer coding in the classroom. And then finally, we're getting to functions. That is our end goal. You'll notice there's no object-oriented in here. There is now object-oriented programming mandated for year 11 and 12 coming from next year in the New South Wales syllabuses. But this, I'm mostly talking about stage 5, which is years 9 and 10, when they've passed the very basic, like I made something appear on a screen thing, and they're now transitioning into doing more complex stuff with functions. Okay. This is the fundamental problem we're trying to solve. So that's the fundamentals. That's all the stuff that I just spoke about. We've got output, we've got variables, we've got input, we've got selection, we've got loops, all of the complexities of interlacing those, and we've got functions, and you're still a million billion miles from GUIs, right? It's very, very far. And it's hard, you have a budget, and also there's physics involved to get you from one to the other. And so this is the problem that we all have to try and solve in our classroom somehow. All right, so today we have made the game Flappy Brick. And I've made this game twice. I've made it in Pygame, and I've made it in Pygame Zero. And we are going to compare the two and see what's going on and why they're different and what's good about them. So it's the easiest game I could think of that I could make with the least amount of physics. So what we have here is a game character, a sprite, and you click a mouse button and it goes up. It does not go up in any smooth way. Please don't critique my code. It's really aimed at 14-year-olds, all right? So it doesn't go up in any kind of smooth animation. It just jumps 30 pixels, and the pipes, or the obstacles, move from left to right. So the sprite goes up and down, the obstacles move left to right. That's the whole game. It's real basic. There's only one input, and the score is based on some basic mathematics. Okay. So why games? This is an important question. I've had some very interesting debates with some people I really respect who say, do not teach games in the classroom, you're killing your children. That gap that I showed you earlier that we have to bridge between the fundamentals and the GUIs is just too great and too disappointing, and so we should just steer clear of games. But I think there's a really good reason for games in the classroom. And that is that kids don't know anything about the world. So when they have to try and come up with the rules involved in some kind of business case, they are at sea. They have no idea. You have to give them to them. Whereas with a game, they have a lot of experience playing games. Different kinds of games maybe, that particularly there is a bit of a gender split in the kinds of games that the students play, but they've still all had some experience with games. And they find games engaging. Amazing. Surprising things, I know. But they're very strictly rule-based. A student, if you sit down and say, how do you play noughts and crosses, they can tell you the rules. They know the rules. They've synthesized that games have rules, and these rules are very easily articulated. And they want to test their programs. Geez, as a computing teacher, we want kids to want to test their programs, and they want to test them if they're games. And it's easily synthesized. Why not games? Because GUIs are really, 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 really hard. Okay. Why Python? Lots of people say you should start with something else. Maybe you should start with JavaScript. Maybe you should use web stuff. It's mostly for the reason that Jack showed in his previous talk, which is that you get rid of all of the stuff that you say, please ignore this until later, and you're left with Python. So we're just going to start with Python. Also, Python is now mandated at the HSC. From 2025, so the students that come into software engineering in year 11 next year will be required to write Python in a browser window in their HSC exam. And so if we're aiming there, we need to smooth that path. And so at our school, we've decided to go 7 to 12 Python. So consistency. I also love that Python has that low floor and very high ceiling. There are lots of things that students can do to extend themselves with all of the different open source libraries that are available to them with Python. There are some students that do extend. I have students who come to me and say, I want to do my major project in Rust. And after I stop weeping, then I say, sure, you're going to get a lot less hand-holding from me. And they're like, it's all right, miss, I'm fine. And for the kid that's, it's all right, miss, I'm fine, then sure, go do Rust. But for most of them, a vast majority of the students that I take through the HSC still need a bunch of hand-holding. And so it's better if those resources I can make once with one language. The other thing is that in the HSC in 2025, not only do the students have to write Python in the browser, they also have to know HTML, CSS, and some SQL. And that's a lot. That's enough now. Keeping those syntaxes straight, I know that the whole HTML is not a programming language thing is great. Have that debate outside. But also, it's still a literacy that they need to have. It's still tagging. It's still things that they need to remember. And there's a lot of cognitive load there. there are a couple of talks a couple of years, there was a great talk a couple of years back about all the different options. If you've decided to do games in Python, what's available to you? And so I'll direct you to that because I'm not going to cover that today. We're assuming that our solution was Pygame. And there are lots of reasons. The number one reason was I didn't want to start with objects. And there's a lot that you can do in Pygame with using objects without having to write your own, without having to write classes. And that's where I needed to be. Okay, so the first thing I want to do is show you a snippet of a tutorial that I've made for a Pygame from before I started using Pygame Zero. And it looked like this. Okay, so I've got little snippets of code. I've got explanations of how things work. And you can see the main loop here, while not done, for event in Pygame. We're going to have to go and get those events. This is just the code to make the screen close. So once you run this code, the screen will close when you hit the little X button. That's it. And there's quite a lot of lines there. All right. So in general, we're talking about games that are single screen, and they follow a very basic, same general shape. Okay, I'm going to show you the shape of a basic game. We begin, we set up the game stuff. There's a whole lot of stuff that needs to be set up in advance. And then we enter a loop, and then we handle the player input. We update all the objects, we draw everything to the screen, and then we check, have we ended the loop or not? And then we do it again, and we do it a lot. And then at the end, we do some endy stuff. Maybe there's a high score or something like that. And then we end the game. That's the shape. This is the shape we'll be referring to for the remainder of the talk. Okay. So, initial setup. I'm going to do the comparison side by side, Pygame, Pygame Zero. All right, so on the left we have Pygame, and on the right we have Pygame Zero. So I don't know if I can do this. Can I do this? Oh, geez, I have little red dots. I love it. Okay, so all right, so Pygame Zero has been made to try and smooth the transition from Scratch to Pygame, to using Python in GUIs. And I'm not sure, I don't have students that are trying to make that jump from Scratch directly to Pygame, so I'm not sure if it's successful there, but there are some great things about it. So it's done a lot of what Jack was talking about in the last talk of wrapping up the craft, I guess. So here we have to, in Pygame, we have to define our colors, and we have to make the tuples of the RGB. We have to do this thing here where we set up a screen and we give it a size, but the size has to be a tuple, or in this case it's a list, but has to have the brackets. And so students, the first thing a student will do wrong in Pygame is to not put double brackets there, which is why I've pulled out size as a separate variable. Okay, and then we have this thing called a sprite. So the brick is a sprite. And that sprite then has to have an image loaded against it, then it has to have a rectangle defined, and the rectangle definition is what you then set X, Y values against. It gets a lot of lines for one sprite being set up, okay? Over here, we have Pygame Zero. This is how you set up a screen. You have one capitalized variable, so constant, I guess, called width, and it has a number against it, and one called height, and it has a number against it. And Pygame Zero goes and does all of the screen creation stuff for you based on those two numbers, which is really useful. And then down here, we have a thing called an actor, which is like a sprite, but with a lot less letters. And an actor takes in it the name of the image. So this is the name of the image. It's in images/brick.png. So it's in exactly the same place. I actually have a GitHub at the end where both of these pieces of code are, so you can see that the images are in the same place. And so if you put the image in the images folder, which is really good practice, and they're all PNGs, then it just works as a string like this, which is magic. The other thing is that over here we have that whole rectangle thing where to make it move and set its X value, you have to do 3 lines of code. Over here, brick just has its own X and Y value. There's also an extra step where Pygame Zero has re-registered X and Y to be the center of the image. Whereas, does anybody know where Pygame automatically puts the XY value? Top left. Yeah, explain that, and I have. So everything is built from the top left, whereas in Pygame Zero, things are built from the center out, which is just useful. Okay. All right, so that was the initial setup. That's all the stuff that happens before the game loop. And now we have the game loop itself. Okay, so I have the function here, update all, and the function here, display all, right? And over here, I've got a function update and a function draw. In Pygame Zero, you are required to use the function name update and the function name draw. So it will do the update thing and then the draw thing, one after the other, inside the loop. Over here, I could call them anything, which is why I called them slightly different, so they didn't get confused. The global's still required, but you can see here the positioning of the different sprites is much trickier in Pygame than in Pygame Zero, and the collision detection is actually yuckier too. So collision detection, where collide rectangle between the brick and the wall top, and the brick and the wall bottom. Over here we've got this collide rect, but it has to be brick rect and not brick itself, and wall top rect instead of wall top. So it's just an extra thing that they have to keep in their heads. And this is every single mistake a kid has made has been anticipated and kind of corrected in Pygame Zero, which is amazing. The last thing I want you to look at is down here, I have brick.draw, walltop.draw, wallbottom.draw. Fantastic, right? You know what that does. It's almost like English. Over here, we have screen.blit, brick image, britrect x, britrect y, right? What the heck is a blit? This is the heck of a blit, okay? So you have a set of pixels and you have to mesh them, sew them together with another set of pixels, a larger set of pixels like a screen, then that process is called blitting. And I think it stands for something, but that's the process that's blitting. And so blitting is what it's called in Pygame because it's correctly called blitting, but no kid needs to know that. So drawing is the thing that they think of it doing. So the language is much clearer. Okay, so there's our blit. Okay, so now we have, they're the things that were inside the loop. Now we have the user input and the loop itself. All right, so user input in Pygame is awful. We have to loop through the events. This is the one that I showed you earlier in my tutorial. This is how you make it quit when the top X is pressed. And this is how we find that there has been a button click. We look for an event type of a pygame.mouse button down, and then we jump the rectangle up 30. Up the screen is -30. Same thing over here, up the screen is -30, but we're just using an on-mouse down event. And then the last thing to look at is Pygame display.flip, right? That's not necessary. Now the other thing is, see this while not done? That while loop doesn't exist in Pygame, not at all. There's no loop, it's all implicit, which is a bit wacky. And this is my biggest problem with Pygame Zero, is that it hides a lot. And it does get you part the way across that bridge image we showed earlier to introduction to GUIs, but it doesn't get you all the way. So, in summary, Pygame Zero is awesome. It really does mean that students have that efficacy to do things without constant tutorials, constant hand-holding. That is really useful, but the questions that are asked are, I know how a function works, why have I defined this function but never called it? And it's because Pygame Zero calls the function itself. It calls the update function, it calls the draw function by itself without the user without the programmer having to do it, which is confusing to smooth the transition to the next step, and it's confusing to the students who know how functions work. So it's really quite useful for the students that are making that first jump in, but it doesn't quite bridge the gap well enough to do the jump out to the next stage, which is taking on, I guess, Pygame by itself. And so teachers, like I've been doing this a long time, teachers that embrace Pygame Zero because look how easy it makes this stuff, are going to need training and support to have those conversations with their students to bridge the gap to the next step and help them understand why there's some magic going on there and how much magic, I guess. So there are some downsides. We have a bunch of functions that are never called. It obscures too much in some aspects, and it makes the next step for novices very difficult. But in conclusion, in conclusion, I'll continue to use it, but I will be doing it with these conversations that I've already rehearsed with my students to make sure they understand that there's some stuff being done there for them. And that is my GitHub if you want to go play. Thank you very much.
Thank you, Amanda. Gaming, I love it. It certainly is a way to engage our students. Do we have any questions out there? Oh, they're all in awe.
It's because I explained everything so well.
I know, you're such an educator. True and true. And I do think that you will have some conversations in the changeover time with maybe Dr. Allison about the physics that your game does not hold yet and the unrealistic
She's
movements.
much better at physics than me.
Yeah, so whoever said that science and gaming doesn't ever overlap, it really does. So I'd like to say thank you, Amanda, while we... and there'll be a very short break while we mic up our next victim guest star. Thank you very much for this, and congratulations on being one of the very only times that we let the border between organiser and presenter, but obviously very well worth it. So thank you very much again. Thank you.